in number 60 on page 434, we have a definite integral from 0 to 2 from 3x squared dx, everything divided by 1 plus x cubed, everything to the 5th power. Very good. Okay, so of course, this is the problem here. And I will say let y be 1 plus x to the third, as long as dy is in the problem. And it is. So it's right up here. So then the whole integral becomes, when x is 0, y is 1. When x is 2, 8 plus 1 is 9. And the numerator, I mean the top part is dy, and the denominator is y to the 5th. So this is the integral from 1 to 9, from y to -5 dy. And that becomes y to -4 over -4 from 1 to 9. You know, I always like to simplify the calculations as much as possible. So this becomes 1 over y to the 4th from 1 to 9. So we have a -1/4 in front. When I plug in 9, how much is 81 times 81? Anybody? 81 squared? Yes, 6561. So 1 over 6561 minus 1. Yes, you can distribute or just factor out -1 if you'd like, because there are too many negatives. So 1 minus 1 over 6561. And you can perform this operation. So this is 1/4 6560 over 6561. So I'm going to divide, see if 6560, if I divide it by 4. Yes. So I have 1640 over 6561. And this is divisible. They are both divisible by 3. That's 11. No, they're not. So this is it. Any questions? Of course, I recommend check with the graphing calculator to make sure that the numbers are correct. Is this okay? Anybody?
Yes.
Good. Next question. Anything else you have?
Could we do question 20 on that same page?
Yes, of course. So let's look at 20. I see it. So 20 again on 434. This is an indefinite integral, dx. Of course, x cannot be -1/4. Okay. So I'm going to say let y be 2 plus 8x and dy equals 8 dx. So I need to multiply by 8 and divide by 8. So there is 1 over 8 in front. There is the indefinite integral of 8 dx, which is now dy, and the denominator is y. So this is 1 over 8, natural log of the absolute value of y plus a constant c. And I have no choice but go back because this is an indefinite integral. So 1 over 8 in front, natural log of the absolute value of 2 plus 8x plus a constant c. Good. Anything else?
Yes, thank you.
Thank you. Anything else? Other questions on anything? Anyone, please? Anything else? Are we okay with chapter 4? Can we move on from chapter 4? Anyone else needs any practice on chapter 4? Anyone? Okay, can I start chapter 5 then? In chapter 5, we have to look at 2 sections. Is that okay, everyone?
Yeah.
Okay, in chapter 5, we're going to talk about applications of integration. We are only looking at 2 applications. Number 1, consumer, producer, surplus. And the second, very simple differential equations. This is section 5.1 and this is section 5.7. That is all we cover in chapter 5. 2 sections. And then we're going to move on to chapter 6, which is the last chapter of this course. Okay, so we're going to start with the consumer and producer surplus. I wanted to share my screen. I have it ready here, just to make sure that everyone is in the clear with this. We are only going to look in chapter 5, section 5.1, only at consumer and producer surplus. We are not going to cover price floors, price ceilings, and deadweight loss. Okay? Just consumer and producer surplus. So, if you remember a long time ago when we reviewed a lot of algebra at the beginning of the course, we talked about demand and supply. And we looked at the equilibrium point. Where everyone is happy. The producers are happy, the consumers are happy at the equilibrium point. And we looked at different situations and we found the equilibrium point in all sorts of different functions, etc., etc. So if you remember the 2 functions, the demand and the supply, here's an example. Here's the demand function, d of x, and let's say this is the supply function, s of x. And this is the equilibrium point. And remember, this is the number of units, x, and this is the price per unit. And this is the equilibrium point. So whenever we purchase, let's say, quantity Q of number of units, we get a price per unit. Let's call it P. Again, we are looking first at the demand function. So I'm just going to take it out of there. I just want the demand function only to look at for a moment. So let's suppose we are looking at this number of units, Q. It can be the equilibrium point, it can be any other point, it doesn't matter. At this price per unit. Notice that if we want to, as an example, let's say I want to buy 5 units of something at the price of $3 per unit. How much am I going to spend? This is my expenditure. How much am I going to spend? 5 times 3. Base times height. This is an area. What is this area? Well, base times height. So it's Q times P. In this case, with my examples 5 and 3, is 15. And this is what I'm going to spend. And this is my expenditure. It turns out that every time I buy 5 units at $3 per unit, I also have this area under the graph of d of x. And this is what we call the consumer surplus. This is consumer surplus. This is no good anymore. Consumer surplus. What does it mean? Well, it means that we are paying $15 for these 5 units. This is what goes out of our pocket. But we are actually getting a little bit extra. What is the little bit extra that we are getting? Exactly this area. If I want to determine the consumer surplus, CS, how will I find it? How will I find this area? Very simple, knowing that we just finished chapter 4. I will have the integral from 0 to Q from d of x dx. This is entire area minus the area of the rectangle, Q times P. And this is the formula for something that we call the extra that we get every time we buy whatever number of units at whatever number of whatever price per unit. This is our extra that we're getting. It's included in we're paying only 15, but we're getting a little bit more for the 15 that actually we see here. What is the extra? Is this piece in US dollars, of course, but is this extra that we get whenever we buy 15 units at this price, 5 units at this price per unit, a total of 15 as expenditure. Okay, so let's continue now with the supply curve, and let's see what is the producer surplus. They also get some extra from selling us 5 units at $3 per unit. So let's see what happens there. Okay. Stop me anytime if you have questions, please. Okay. So here is the producer or the supply curve. Let's say this is the point. Again, this is the Q. This is the P. Now, in this particular case, this is the producer surplus. So in other words, they're giving us 5 units at $3 per unit. But they're actually getting a little bit more out from our expenditure. We should have paid less, in other words, than $3 for 5 per each unit and pay $15. We should have paid less. They are also getting some sort of extra quantity. But how do I determine that? Okay, so in order to find this area, which is the producer surplus, this time it's the reverse operation. I have the rectangle, which is P times Q, minus the area under the graph that we discussed and we determined in chapter 4, which is the integral from 0 to Q from S of x dx this time, because this is above the curve. So this is the area of the rectangle from which we subtract the area under the graph of S of x between 0 and Q. And we obtain this area. So from the total, I subtract the below, and I get this area, which is the producer surplus. And this is the formula. We're going to look at examples to see how this works. This is it. 2 formulas. One, as you notice, is the area minus the area under the graph minus the area of the rectangle. The other one is the vice versa. It's the area of the rectangle minus the area under the curve S of x. Okay. So let's open on page, and let's choose problems and see how this works and how we determine the consumer and the producer surplus at the equilibrium point or any other point. Okay, 479. Okay, at the bottom of the page. D of x is the price in dollars per unit that consumers will pay for x units of an item, and S of x is the price in dollars per unit that producers will accept for x units. Find part A, the equilibrium point. This is just algebra. We've done that a lot at the beginning of the class. No problem there. Then find the consumer surplus at the equilibrium point, and then find the producer surplus at the equilibrium point. So we have to choose between, among 1 through 4 and 5 through 14. So 1 through 14, anything you'd like to choose. We are asked to find number 1, the equilibrium point, number 2, the consumer surplus, and number 3, the producer surplus. If you don't choose, I will.
Let me do number 2.
Yes. Let's start with number 2. You said 2, correct?
Yes.
Okay, very good. So let's start with number 2. Until we have the demand function negative 3x plus 7 and the supply function 2x plus 2. Okay. So in part A, they want us to find the equilibrium point. Anyone remembers how to find the equilibrium point? What do we need to do in order to find the equilibrium point?
You set them equal to each other?
Thank you, Kali. Yes, of course. We have to set them equal to each other. So d of x equals S of x, negative 3x plus 7 equals 2x plus 2. I move 2x to this side. I move 7 to this side. So I get x equals 1. So the equilibrium point is 1 comma. You plug in anywhere, it doesn't matter. It has to be the same. 2 plus 2 is 4. So for this situation, with the given demand and the given supply functions, we determine the equilibrium point. And now in part B and part C, the consumer surplus is the integral from 0 to 1 from the demand function dx minus the product, base times height, of the equilibrium point. The other one, the producer surplus, is this product minus the same integral from 0 to 1, but from the other function, from the supply function, 2x plus 2 dx. Of course, we're going to calculate them. I just wanted to put them there so you can see them.